All right, so a quick additional piece to our last video. Our last video basically talked about how you create a line of best fit. And so we started out by typing our table in. And so here's the table that we had from our last time. And so we have our table already typed in. And then we created the line of best fit here. And we did that by typing Y1. I'll do that one more time just so you guys can follow along. We typed in Y1. That one automatically goes down to the bottom right hand corner. Is approximately, that was our squiggly line, approximately M for slope, X1, and plus B are a y-intercept. So that creates this line of best fit. And we had typed that out the previous time. We'd actually written it in. But what I also want to do is I also want to create actual lines of best fit in order to make predictions. So our bigger goal now is, can we actually make a prediction using this line of best fit? So it takes a couple more steps, and I want you to kind of see how those steps end up coming together. So the first thing you're going to do is in the next box right below the line of best fit data, we're just going to type in the regular slope intercept form equation. Okay, so y equals mx plus b. I'm going to change that from blue to red just so you guys can see it a little bit better. Okay, so you can see that when I type in y equals mx plus b, I didn't type any numbers, but what it's automatically doing is this m value that I have highlighted is this value. They're automatically using the parameters, the m and the b that were calculated previously. So it automatically graphs this y equals mx plus b equation. And notice you can actually drag your cursor along that equation. So you could do this if you wanted to. If you wanted to make a prediction, you could just actually drag your cursor along and see what those values are. But there's a better way of doing it as well. And we do it by returning to a table. So notice that this table was the table of actual data values that were given to us in a problem. But I want to create a table that is based on our line of best fit, because you can notice, you can see that this blue point isn't the same as the red line. So I want to create a table out of these red line equation, this red line equation. So here's what we do. We've got our y equals mx plus b. And next we're going to come up here to the top and we're going to click the gear icon. It's going to come up with that word that says edit list. So when you click the gear icon, you'll notice that everything changes on this right here. We can delete that one. I don't necessarily need it. So on here, you'll notice that there are some different options. And the first one is a table icon. And if you hover over it, it says convert to table. That's exactly what we want to do. So I'm going to click on convert to table, and it converts that equation into a table of points. Now it's automatically going to use -2, -1, 0, 1, 2. Those are my x values that are going to be plugged in. Now, if you remember back to our previous video, these were actually data values of the week we were in and the number of miles we were running. So remember, up here, week 2, we ran 8 miles. And our prediction is pretty close to that. Week 2, we're running 8.04. That's really close to the actual amount. But what if we want to make a prediction? What if we wanted to say, well, how many miles? Notice that week 5 wasn't on the table. So I want to make a prediction for how many miles we're going to run on week 5. So we're just going to add to the bottom of the table. So you're just going to click in the next available box in the first column, the X column, and you're going to type in any number you want. So since this time we're trying to figure out week 5, we're simply going to type in the number 5. And automatically your prediction populates on the right-hand side. So our prediction is that on week 5, we're going to run approximately 13 miles. And we could use this as far as we want. We could jump all the way till, well, what about on week 15? Wow, now we're running 29.76 miles, approximately 30. So we could predict as far out into the future as you want, 30 miles. Now we're running 54 miles, almost 55 miles. That sounds pretty ridiculous because I don't think anyone's running 55 miles a week. But this is the point, is that we need a line of best fit, and we use that line of best fit to make predictions. And so this is going to make predictions. We can predict as far as we want. Now, we would want to keep reality within check, right? And we're probably not going to run 54 miles. So our line of best fit keeps going infinitely, but within the reality of the context, we're probably not going to get to 55 miles. So at some point, our line of best fit stops making sense, even though it exists infinitely. So there you go. That's our method, the manner in which we find our line of best fit, and the manner in which we use the line of best fit to make a prediction. So once again, we type our table in. We then type y1 is approximately, squiggly line, squiggle, squiggle, approximately mx1 plus b. That creates our line of best fit. I'm going to redo this part right here. That creates the line of best fit, but then we then need to type in y equals mx plus b. So that gives us the line itself, but it doesn't give us the table yet. So to get the table, we go up to the top, we click on this gear icon. Once we've clicked there, we return to the question itself, the equation itself, and we click on convert to table. That then gives us our table, and we can make any prediction we want by clicking in the next available blank box in the X column. You never want to click in this column because this is the dependent variable. The dependent variable depends on the X column. It depends on the X variable. So we're going to make any prediction, 7, 12, anything you want. It predicts those values for you, and your solution or your answer would be in this column right here. Best of luck. Keep up the good work.